hello there, my jungle friends. And it's time for another episode with Can We Do Common Core? Hey, look at this here. What do we have? We have a new doggy. Yes, Mr. Warrior, you keep changing your avatars. You're totally confusing us, dude. Hey, change can be a good thing. Hey, this guy's kind of a cute dog. Come on, how could you not like that face? Anyway, let's get started here with this fun old math video. This is one that actually we did kind of live in class as we covered this material already, so this should be, like they say, a walk in the park. I have my screen shade on there because I'm hiding some very important data behind. Let's go ahead and take a look what we're going to be focusing on. Now we're covering a whole new area, my friends. Fractions. We've been working with decimals quite a bit. And what am I doing here? I look really, really lost. Magic pen. There we go. So anyways, this is what we're looking at now. As you see, I'm going to start listing the topic because they have the module broken up in pieces. So topic A is going to be about equivalent. And equivalent means like the same. Okay, like having the same value. So equivalent fractions that are the same. You could look up the word equivalent. Equivalent doesn't always necessarily mean exactly the same, but it means it has the same value. Think of it that way. But anyway, here we have our SWABAT, and it means students will be able to. So you're going to be able to make equivalent fractions, okay, with number line, area, model, and numbers. Now, something to keep in mind, this is 4th grade, okay? So there's a couple of lessons that are launching this new topic on fractions, but again, you may recall that last year you did this. Anyway, by the way, don't be confused with all this magic pen stuff that has nothing to do with that secret code. Anyways, we're going to go ahead and take a look at this application problem. You recall we did this in class, so I'm going to just kind of move along and do it rather quickly, I might say. And as you can see, we have 15 kilograms of rice. It says 15 kilograms of rice are separated equally into 4 containers. Okay, 15 kilograms of rice separated equally should be that should be like a red flag. Hello, division. Okay, it says into 4 containers. How many kilograms of rice are in each container? This is a question. Express your answer as a decimal and as a fraction. Okay, well, first things first here. We've been doing a lot of this tape diagram, and I'm going to go ahead and represent it as such. Yeah, we'll do it like so. Looks good to me. And then let me go ahead and do my nice little cool, something like that, right? This is going to represent all of the rice, the 15 kilograms of rice. Okay, now we're also going to need, I'm just going to use, we'll use it right again. Why not? And since we're breaking this up into 4 containers, 15 kilograms of rice are going to be separate equally in 4 containers, then I want to go ahead and take all that rice and separate it into 4. Okay, now what it's asking us to do is how many kilograms of rice are in each container. So in essence, this right here, I don't know what the value of this 1 unit is going to be. I do know that 4 of the units, 1, 2, oops, I was meant to put it 2, 3, 4 going across, okay, equals the whole. So I could put this on the side here. And that, of course, is going to equal our 15 kilograms. Oop, learning how to spell. And so with that, gets us kind of on our way to the next step here, which is we're going to need to divide. So as we have our 15 kilograms, and I'm just going to put a couple of zeros there, not that I'm going to need that, but I happen to know if you divide that, we're not going to have a whole number, so we're going to have to work this out in a decimal. So 4 will go into 15, 3 times, giving us 12. We subtract and get 3. Okay, we're going to bring down our 0 here. Don't need to draw the arrow, just showing you what's happening. 4 goes into 30, 7 times? That's giving us 28. 2 left over, and then we bring the 0, you can see 5 goes in there. Okay, so we end up with 3 3/4, and we can represent this as 3.75. Now this is, keep in mind, this is what 1 unit is going to equal then right here, okay? 1 unit, and then I'd have 4 units altogether. Now we could also represent this as a fraction. Okay, now interesting, the 3 doesn't change because the 3 is the whole. We can't put that as a fraction. I mean, you could put it 3 over 1, but that's basically your whole number part. So then we just need to take this 0.75 and represent that as a fraction. Well, this is a decimal, 7/7500, so this could actually be written as 75 over 100. Okay, now there's nothing wrong with writing 3 in 75 hundredths. However, it just so happens that 75 hundredths can also be written as a reduced fraction and an equivalent fraction, what we're going to be looking at today. So if we were to divide out, for example, a common factor from the numerator and the denominator. So our 75 is the numerator, our 100 is the denominator. We could divide out a 25 because a 25, like quarters, will go into 75 3 times. So we can think of 75 divided by 25 equals 3, which also, of course, means 3 times 25 equals 75. If we divide 100 by 25, that's going to equal 4. And just like that, you can see that this is a reduced fraction. So this would really be written in 3 3/4. And the and still comes in there because we have something less than 1 whole. Okay, so we're going to go ahead and move on. You know, this is kind of weird. It's just, do you see this bowl of rice move a little bit? I thought I had. Maybe it's just my imagination. Or maybe there's a gorilla hiding behind it. Yeah, that's right. Mr. Orr was on to you, buddy. Yeah. Did you make any noise? I couldn't hear him. Uh-oh. Maybe it's not functioning. Cancel. Oh. Oh. All right, buddy. Calm down. Must have clicked it so many times. Sorry, I had to do that. Anyway, all right, let's go on to the next page. All right, wow. What do we have here? Oh, man. Camel, dude. What are you doing? You're on my page, man. Delete. 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 Thank you. Whoa. That's a lot of work. Didn't realize that. Yeah, I didn't want to get mixed up with my other work here. All right. So we're looking at, again, another problem. And it looks like we're going to be looking at the concept development piece. I do believe on page 2. Yes. And let me get a pen. All right, let's get started here. So here we have a number line. And we have these weird objects which we're going to take a look at. You recall in class that we did do something regarding with paper strips and breaking things into halves. And basically that's what we're going to do here. We're going to just kind of show representation here. So if we showed a number line, 0 to 1, okay, and we wanted to break that whole into halves, of course this would be 0 out of 2, or we would say 0 group of 2, okay, and then over here we're going to have 2 group of 2. You can see that right here in the middle we're going to have 1/2. Okay, so here we have our number line. Now what I'm going to do is just kind of pull this up, and we could actually represent this. Let me get a little bit smaller, like so. Okay, so if we wanted to represent 1/2, we could come in here, and I guess you could do a lot of different things, but we're going to do it here with the shading, I guess. Okay, we could show 1/2 by simply shading in one part of this whole here out of 2. I'm not a really good color, am I? Okay, I went outside the line. Anyway, so that would be a great way to do that. We'll fix that right now. And represent 1/2. And because we have one group of 2. Now, we could also represent this as another fraction with the same, let me see if we can get the same size. There we go. Okay, so let me write the numerical expression, sort of. Okay, so this is going to be 1 over 2. Now if you notice, I had the exact same whole, the same size, but now I've divided it into 4 equal parts. Now interestingly, what we can do is we can actually shade in our same half here, but look what's happening here. Okay, see now what we have is we basically have 2 equal parts, okay, of the 4. We still have our same quantity. That didn't change. If we don't overlap that, which I'm going to have some fun here and do this here. Okay, if I were to go ahead and do this, and just group this real quick. See, I can put that right on top. See that? It's the same quantity. It's equivalent. Therefore, 1/2 would equal 2 of 4. Okay? 2, here we have 2 groups of 4, and this basically states this. Now, another way we kind of look at this, if we write the numerical expression, is basically then 2/4 then is equal to, basically what we did was we multiplied this by 2 and that by 2. And look how that gave us our new fraction. The 1/2, okay? And basically it was kind of like doubled. And we could write a lot of different equivalent fractions. Here's another one. We could close. Ooh, just about. I'll keep these somewhat the same. See, now again, look what happened. Now we've divided in our same whole again, different. So I'm going to quickly fill this in. Okay. Notice I'm doing the same half, but now they've been divided into 6 equal pieces. The 6 equal pieces is going to become my denominator. And then how many are shaded in? I have 3. So I have 3 groups of 6. And again, showing that same. Look what happened. Here, from that 1 then fraction, we multiplied the 1/2, okay, by 3. See how that worked out? 1 times 3 is 3. 2 times 3 is 6. Okay, same quantity, it's equivalent. And we still have another one we can do here. So let me open it. Open up. Okay, now as you can see, now we have 8ths here, looks like. Whoa. Little large. Okay. And we do the same thing. And I'm rather than do the shade, I'm going to go right to, if we had all that, we would have the 1/2 times, and here we would have 4 times 4 is 4/8. Okay, so what we've basically done here is we're showing the equivalent fractions. We did it here on a number line here, showing you the fractions here. And we also showed you the area model, because this is the area model here. And we also showed you the numbers. Okay, and this is what the objective was. Okay, let's go into the next one here. Oh, cool. We have a tiger. Yeah. See, gonna make a sound? Ooh. Oh, you got kind of big too, huh? All right. Cool, nice to have you. Going to move on. Okay, so now we're going to make fractions that are equal to 1/3. So let me bring this down. Let's do this here first. Thank you. We'll bring it down like so. So again, we're going to represent this on the number line. So here we're going to have 0 would be our, basically here we're going to be looking at trying to do this in thirds. Well, again, it's like 1 whole. Okay, so this is going to be 3 of 3. Here we have 0 of 3. And then let's look at what happens to the numerator. We're just adding that 1. I'm sorry, not 1/2, 1/3. Stuck on my last problem in my head, I guess. Okay, let's try that again. Okay, so this would be 1 of 3 and then 2 of 3. And then we have 3/3 right there. So again, we could represent this as our area model. Okay, here's our whole. And basically what we want to do is make it a little bit smaller. Try to put these in between. And then I'm going to need a couple of these because we want to show some equivalent fractions. Oh, come over here. Come over here, thank you. Okay, and we'll put you up here for the time being. So here we want to go ahead and represent 1/3 is what it's asking us to do. So let's first start off with the first one here by, we're just going to divide this. Normally I have a nice little lines, but I'm going to do it this way so you guys can see that, yes, I don't have all the modern conveniences. Okay, and I'm just going to shade in this here, showing my 1/3. Okay, and this is 1/3. Okay, and now again, remember how we did that times 2? Well, we can make an equivalent fraction by going ahead and multiplying the numerator and the denominator by the same quantity. And if you notice, now we have 2, and then 3 times 2 is 6. So 2/6 would also equal 1/3. So let's go ahead and show that. So now we need 6. So if you notice, we could just take our same thirds and now just split this in half. So now I have 6 equal pieces, and I'm going to need to color in 2 of them. Okay? Now I have 2 6. Easy peasy. Okay? Now, again, we keep making a new one, another one, another one, but I think I'm going to move on to the next problem because I think this is pretty straightforward. You know, we take that 1/3, and if we multiply, okay, this is going to disappear. Okay, by 3, so you then wind up with 3/9. Okay, and again, we can show that model. We could do the same type of thing here. We could, you know, probably go like this, and then break that one into thirds. See, now we end up with our ninths that are, okay, equal. And we keep making another equivalent fraction. It seems so easy. Okay, we'll move on to the next page here. Now, this is the one that may be a little bit trickier. Look at our fraction now. See that? The 5/4. So 5/4 is a fraction, but it's called an improper fraction because you see we have more equal parts than there are. Like this lets you know that we're going to be dividing the whole into fourths, but we have 5 of them, and that's more than one whole because 4/4 is one whole, but we have 5/4. So that's going to make this problem a little bit challenging. Not that big of a deal though. Nothing that's going to make us nervous. No, I don't think so. So here we have, again, our 0. And now, in this case, probably want to show the 5/4 here. Now, I don't think this number line is going to work that great, so we're going to maybe do, take that back. Let me do this. Thank you. Because what we basically need is we need to, first of all, find what our whole is going to be. So if that's 5/4, might even be better to do this. Let's just kind of ignore this guy for the time being and just say that's going to be my whole here. So this is going to be my half. And I'm just kind of thinking fourths right now. So I'm trying to make 4 equal pieces. See that? And then that way, now I have 1, 2, 3/4. We'll do one more. See, that'll be that guy right here. Bring him over. All right, that would mean that this one up here is going to be 4/4. Okay, and then here we have 3/4. And, oh, you know, I usually did those at the top, but let's put those down here. Let's do it this way. 0, 1/4, 2/4, 3/4, 4/4, and then we're just going to grab this guy, bring him down here, and then we'll just, that way we can keep this part the same. And then here is our 1, because we're looking at that before. Okay, so now if we pull up our area model, you can see that we're going to want to break this into fourths here. So let me go ahead and start to do it this way. So I can make this a little bit longer. Or was it the square to begin with? I wasn't sure. Okay, so basically what we'll do here is we'll just start off by showing that 5/4 so break this here and like this here. Now we're going to need another one of these because this completes. Here we go. So now we've got this 5/4. Here's our 1. See, 1, 2, 5/4. And we have 5 of them. And if you look at that, you can see that we have 1, 2, 3, 4, 5/4. And then we basically have, that's 1 and 1/4 because we have one whole and then we have 1/4. And you can also make an equivalent fraction. So you wonder, well, how are we going to do that? Well, if we do this, and let's just grab, and say we're just going to multiply that by 2. This is how we make our equivalent fractions. So now we have 10/8. Well, here we could easily, because we're multiplying by 2, it's almost like you're doubling this. So if we would do this and this, so it was all equal pieces. 2, 4, 6, 8. Yeah, that works. 2, 4, 6, 8. And then we can do the same thing over here. So that's our denominator. Now, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 over 8. Still same quantity, okay? You see, I'm just showing you 1, 2, 3, 4, 5, 6, going over 7, 8, 9, 10. So you knew I was kind of counting there. And 10 over 8. And this pretty much concludes, so what we've looked at in this, basically, in this video here is how to make equivalent fractions. Again, it's review. So, my friends, that is the conclusion of this video. Okay? And you have these beautiful, beautiful little syllables you have to put together to give me a code word. Live long and prosper, my friends.